So cadets, in last period, we discussed about the hydrolysis of salt and particularly hydrolysis of salt of strong acid and strong base. Hydrolysis of salt of strong acid and strong base. And it is observed that on hydrolysis, or you may say that the salt of strong acid and strong base never undergoes hydrolysis. Never undergoes hydrolysis. जो इक्वेशन फाइनल इक्वेशन हमें मिला था हाइड्रोलिसिस करने के बाद स्ट्रॉन्ग एसिड और स्ट्रॉन्ग बेस के सॉल्ट का, वो था H2O dissociates as H plus and OH minus. Today we have to discuss hydrolysis of another three types of salts. एक सॉल्ट का हाइड्रोलिसिस हुआ था सॉल्ट ऑफ स्ट्रॉन्ग एसिड एंड स्ट्रॉन्ग बेस. अब हमें आज तीन जो अनदर सॉल्ट है उनका हाइड्रोलिसिस देखना है. सो फर्स्ट सी द हाइड्रोलिसिस ऑफ सॉल्ट ऑफ वीक एसिड एंड स्ट्रॉन्ग बेस. वीक एसिड एंड स्ट्रॉन्ग बेस. अब अगर हम वीक एसिड और स्ट्रॉन्ग बेस कंबाइन करते हैं, वीक एसिड एंड स्ट्रॉन्ग बेस, लेट अस कंसीडर वीक एसिड CH3 or COOH, strong base NaOH. OH and H goes off. OH and H goes off, and it produces CH3COONA. Similarly, अगर हम जनरल इक्वेशन लेते हैं एसिड के लिए, एसिड इज HA, बेस इज BOH, तो ये OH और ये H निकल जाएगा और सॉल्ट मिलेगा हमें BA. कौन सा सॉल्ट मिलेगा? BA. So let a salt BA. इससे पहले क्वेश्चन देखते हैं. क्वेश्चन, it is observed that this type of salt of weak acid and strong base strong है, इसलिए जब हाइड्रोलाइज करोगे तो बेसिक सॉल्यूशन मिलेगा. As in the salt of weak acid and strong base is strong, and hence basic solution is obtained on hydrolysis. So question is, explain on hydrolysis salt of weak acid and strong base produces basic solution. Produces basic solution. Let a salt BA, जो इस तरह से मिला BA, let a salt BA of salt weak acid HA and strong base BOH. Let a salt BA of weak acid HA and strong base BOH, which dissociates as, कैसा dissociate होगा? BA dissociates as B plus plus A minus. Now, hydrolyze these cations and anions from the salt. B plus on hydrolysis, B plus plus A minus from the salt combines with water and it produces, you know that when salt is hydrolyzed, it produces acidic and basic solution. So it produces base BOH and acid HA. Acid HA. But you know that here, this is the salt of weak acid. So HA, whatever the acid obtained, it is weak. And whatever the base obtained in hydrolysis process, it is strong base. And you know, according to Arrhenius, strong base is completely dissociates, whereas weak acid is not completely dissociate. तो ये HA completely dissociate नहीं होगा, इसलिए इसे ऐसे ही रहने देते हैं. But BOH is strong base, hence it completely dissociates as Ba dissociates as B plus and OH minus. Add this value in this equation, hydrolysis equation, we get B plus plus A minus plus H2O. BOH is hydrolyzed as B plus OH minus plus HA. ये चीज वैसे रहा क्योंकि ये वीक एसिड है। और कैंसलिंग कॉमन आयन कौन से कैंसिल हो गए? B plus cancel with this B plus. So the equation becomes now A minus plus H2O, it produces HA plus OH minus. HA plus OH minus. That means on hydrolysis of this type of salt, finally we produce 3 OH minus ions. And according to Arrhenius, you know that the substances which produces OH minus ion on hydrolysis are base. And hence on hydrolysis here OH minus ions are obtained. That's why this type of salt on hydrolysis produces basic solution. So this is proof that salt of weak acid and strong base on hydrolysis produces basic solution. अब इसका एक एग्जांपल लेते हैं. You know the example of salt of weak acid and strong base. Let us consider a simple example. Weak acid is CH3COOH and strong base is NaOH. So OH from strong base, H from weak acid, it goes off and remaining is combined together. So what will be the remaining? H from acid, OH from base goes off and remaining is CH3COONA. CH3COONA. So this type of salt, the example of this type of salt is CH3COONA, which dissociates as CH3COO minus acetate ion and Na plus ion. इसे अब hydrolyze करो. When it is hydrolyzed, the equation becomes CH3COO minus plus Na plus H2O. So what happens? हमने OH निकाला था Na से, तो हमें फिर से NaOH मिलेगा. H निकाला था CH3COO minus से, hence CH3COOH मिलेगा. So on hydrolysis, it produces weak acid CH3COOH and strong base NaOH. But here again, NaOH is strong base. NaOH is strong base. Hence completely dissociates. Its degree of dissociation is 1. 100 out of 100. So NaOH is completely dissociates as Na plus and OH minus. Now put these values in this equation, hydrolysis equation. We becomes CH3COO minus plus Na plus H2O. CH3COOH remains as it is a weak acid, and NaOH is strong base, hence completely dissociates as Na plus and OH minus. Cancel the commons are. Which are the common ions? Na plus and this Na plus. These are cancelled. So equation becomes now CH3COO minus plus H2O. It produces CH3COOH, which is a weak acid, and OH minus. So finally we obtain 3 OH minus ions, and according to Arrhenius, those substances which produces OH minus ions are basic. So we can say that salt of weak acid and strong base on hydrolysis produces free OH minus ions. That means basic solution is obtained. Now hydrolysis of third type of salt, and that is salt of strong acid and weak base. Salt of strong acid and weak base. पहला हमने लिया था हाइड्रोलिसिस ऑफ सॉल्ट ऑफ स्ट्रॉन्ग एसिड एंड स्ट्रॉन्ग बेस. दूसरा हमने लिया था हाइड्रोलिसिस ऑफ सॉल्ट ऑफ वीक एसिड एंड स्ट्रॉन्ग बेस. और अब हमने लिया हाइड्रोलिसिस ऑफ सॉल्ट ऑफ स्ट्रॉन्ग एसिड एंड वीक बेस. Let us consider a weak base BOH and strong acid HA. When these are combined, it produces water molecule OH and H and salt BA. Salt BA. Let us consider whatever the salt BA obtained, it is of strong acid HA and weak base BOH. Let that salt BA dissociates as B plus and A minus. B plus and A minus. On hydrolysis, what happens? On hydrolysis, these cations and anions combines with water and again produces weak base BOH and strong acid HA. यहाँ पर HA जो प्रोड्यूस हो रहा है ये स्ट्रॉन्ग एसिड है. And whatever the BOH produce, it is weak base. As HA is strong acid, hence it completely dissociates as H plus and A minus. ये HA completely dissociate होगा. Hence, hydrolysis equation now becomes B plus A minus plus H2O. BOH remains as it is because it is weak base. This dissociates as H plus and A minus. Therefore, equation becomes B plus A minus plus H2O produces weak base BOH and strong acid which completely dissociates in H plus and A minus. On cancelling common ions, this A minus cancel with this A minus. Overall hydrolysis equation becomes B plus H2O produces weak base BOH and EH plus ion. So on hydrolysis, this type of salt produces free H plus ion. And you know, according to Arrhenius, substances which on hydrolysis produces H plus ions are acidic in nature. And hence we can say that on hydrolysis, salt of strong acid and weak base produces acidic solution. Example. Let us consider a weak base NH4OH and strong acid HCl. They are combined. So produces a salt of type strong acid and weak base. So NH4OH combines with this HCl, OH and H goes off and salt is NH4Cl. This NH4Cl is the example of salt of strong acid and weak base. This NH4Cl dissociates as NH4 plus and Cl minus. NH4 plus and Cl minus. इसका हाइड्रोलिसिस करो. What happens? On hydrolysis, NH4 plus Cl minus plus H2O, it produces NH4OH, which is a weak base, and HCl, which is a strong acid. As HCl is strong acid, hence completely dissociates as H plus and Cl minus. अगर हम इस वैल्यू को यहाँ पर दे देते हैं, HCl का डिसोसिएशन लेकर हाइड्रोलिसिस इक्वेशन लिखते हैं, then hydrolysis equation becomes NH4 plus Cl minus plus H2O produces NH4OH, which is a weak base, hence does not dissociate, and strong base HCl, which completely dissociates as H plus and Cl minus. So hydrolysis equation becomes like this: NH4 plus Cl minus plus H2O produces NH4OH plus H plus and plus Cl minus. On cancelling common ion कौन से this Cl minus is cancelled with this Cl minus. Therefore, hydrolysis equation becomes NH4 plus H2O produces NH4OH plus H plus. Here finally, aqueous or H plus ions are obtained, and you know, according to Arrhenius, H plus ion producer are nothing but the acid. Hence, on hydrolysis, salt of strong acid and weak base produces acidic solution. Hydrolysis of last salt, and the last salt remain is salt of weak acid and weak base. Cadets, देखा गया है कि ये जो टाइप का सॉल्ट है, सॉल्ट ऑफ वीक एसिड एंड वीक बेस, on hydrolysis it produces either neutral solution or acidic or basic solution. जनरली न्यूट्रल सॉल्यूशन तैयार होता है, लेकिन अगर दोनों के स्ट्रेंथ में, एसिड और बेस के स्ट्रेंथ में डिफरेंस है, तो जिसकी स्ट्रेंथ ज्यादा है वो सॉल्यूशन तैयार हो. हाउ से क्वेश्चन होगा, एक्सप्लेन on hydrolysis salt of weak acid and weak base produces neutral or acidic or basic solution. Let a salt BA of weak acid HA and weak base BOH, both are weak. So BOH and HA combines to produce a salt BA, which dissociates as B plus and A minus. अगर हम इसका हाइड्रोलिसिस करते हैं, then it becomes B plus plus A minus plus H2O. It produces BOH and HA. Both are weak. Hence, they do not undergo hydrolysis and remains as it is in the solution. So, in that solution, both acid as well as base is present. Therefore, that solution becomes neutral. So, on hydrolysis, salt of weak acid and strong weak base produces neutral solution. Depending upon the strength of acid or base, if degree of dissociation of acid is greater than degree of dissociation of base, then acid is more dissociated. At that time, acidic solution is produced. अगर base strong है, तो basic solution produce होगा. Now, let us consider a salt CH3COONH4 ammonium acetate of a weak acid CH3COOH and weak base NH4OH, which dissociates as CH3COONH4 dissociates as CH3COO minus and NH4 plus. On hydrolysis, it produces CH3COOH weak acid, NH4OH weak base. As both are weak, does not undergo dissociation, and hence both acid as well as base is present in that solution. Hence the solution becomes neutral. Solution becomes neutral. Hence we can say that on hydrolysis, salt of weak acid and weak base produces neutral solution. तो ये हमने देखा हाइड्रोलिसिस ऑफ सॉल्ट, और इसमें हमने 4 टाइप के सॉल्ट का हाइड्रोलिसिस किया. हाइड्रोलिसिस ऑफ salt of strong acid and strong base, in which this type of salt never undergoes hydrolysis. The equation obtained is water dissociates as H plus and OH minus. Then hydrolysis of salt of weak acid and strong base, hydrolysis of salt of strong acid and weak base, and hydrolysis of salt of weak acid and weak base. After study of hydrolysis of salt, we have to discuss about the relation between hydrolysis constant, that means KH, and dissociation constant. You know, dissociation constant for acid is Ka and for base is Kb. So we have to find out the relation between hydrolysis constant and dissociation constant. And second relation between degree of hydrolysis H and hydrolysis constant for different types of salt. For different types. And you know, there are 4 different types of salts. इसमें से एक salt हमने कहा था salt of strong acid and strong base does not undergo hydrolysis. यह hydrolysis में जाता ही नहीं. तो ना तो hydrolysis constant रहेगा, ना उसके लिए degree of hydrolysis रहेगी. इसलिए इस salt को छोड़ दो, बाकी जो salt 3 salt बचे हैं, उनसे कौन से? Salt of weak acid and strong base, salt of strong acid and weak base, and salt of weak acid and weak base. इनके लिए ये रिलेशन हमें निकालना है. तो इसमें से हमने पहले सिलेक्ट किया रिलेशन बिटवीन hydrolysis constant and dissociation constant of salt of strong acid and weak base. Salt of strong acid and weak base. तो इसमें हमने strong acid लिया और base लिया weak. दोनों को कंबाइन करके हमें ये टाइप का सॉल्ट मिला, salt of strong acid and weak base. Now see the relation, first relation between hydrolysis constant, that means KH, and dissociation constant Kb for the salt of strong acid and weak base. Let a salt BA of strong acid HA and weak base BOH. ये BA salt तैयार हो, which dissociates as B plus and A minus. ये हमने पहले भी देखा dissociation. Hydrolyze किया, hydrolysis equation किया. So cations and anions from the salt reacts with water and produces BOH and HA. Here BOH is base. Base is weak. Base is weak. And salt, whatever the acid produced, it is strong. And according to Arrhenius, strong acid is completely hydrolyzed. It completely dissociates. अगर ये एसिड HH strong है, dissociate हो जाएगा, which dissociates as H plus and A minus. Now, hydrolysis equation becomes B plus A minus plus H2O. BOH remains as it is because it is weak, and strong acid which dissociates as H plus and A minus. So this equation is okay. On cancelling common ions, common ion कौन से हैं? A minus cancel with this A minus. The hydrolysis equation becomes B plus H2O produces BOH, which is a weak base, and H plus. So this gives acidic solution. ये हमने पहले भी देखा हुआ है. If we apply a law of mass action to this equation, we obtain a hydrolysis constant. Hydrolysis constant की definition में हमने देखा था. If we apply a law of mass action, law of mass action कहता है, it is the product of concentration of product side upon concentration of reactant side. So here the product side is BOH and H plus, reactant side is B plus and H2O. Therefore, on applied law of mass action, K BOH product side plus H plus ion concentration upon B plus H2O. H2O is in large excess, weak electrolyte, hence its concentration is constant. Let us consider the concentration of water is constant and it is K dash. So this K dash, and हम अगर इसे इधर लाते हैं तो ये बनेगा K into K dash, and that is constant, and let us consider that constant is KH. इसलिए हमने कहा concentration of H2O is constant, and whatever the K dash of this, K dash into K इधर लाने के बाद it is KH. Therefore equation becomes KH is equal to concentration of BOH into concentration of H plus upon concentration of B plus. Yes. Now see, suppose this is equation number 1. अब इसमें HA तो completely dissociate हो गया, यहाँ पर HA completely dissociate हो, but what is the remaining side? Remaining is BOH. Though it is weak acid, but it dissociates or hydrolyze, but less hydrolyze. जितना भी hydrolyze होगा, जितना भी dissociate होगा, तो उस weak base के लिए क्या आएगा? BOH dissociates as B plus and OH minus. So, on applying law of mass action, we will get dissociation constant for that weak base. Therefore, concentration of B plus into concentration of OH minus upon concentration of BOH equals to Kb, which is a dissociation constant of weak base. We know ionic product of water. Ionic product of water. और ionic product को हमने कहा था Kw equals to concentration of H plus into concentration of OH minus. ये ऑलरेडी इक्वेशन हमने प्रूव किया है pH लेने से पहले. If we divide Kw by Kb, Kw H plus concentration and OH minus concentration, इसको इससे डिवाइड करो, B plus into OH minus divided by BOH, BOH को ऊपर ला लिया, so equation becomes Kw upon Kb equals to concentration of H plus into concentration of OH minus into concentration of BOH upon concentration of B plus into concentration of OH minus. Common and OH minus get cancelled. Therefore, equation becomes for the ratio of Kw and Kb, concentration of H plus into concentration of BOH upon concentration of B plus. Now see, this equation, let us consider second equation and first equation. Both are same. BOH, H plus, B plus, B plus. As right hand side is same, therefore left hand side should be same. So RHS is equal to LHS. Therefore, this becomes KH is equal to KW upon KB. It indicates that अगर हम इस KW को निकाल दें तो ये equal sign निकल जाएगा and this equation becomes KH is equal to is inversely proportional to KB. It indicates that hydrolysis constant of a salt of strong acid and weak base is inversely proportional to dissociation constant of weak base. Dissociation constant of weak base.